Hello, hi, and I know what you're thinking. This is not Pico 8, this is a paint, and you are correct. Today I want to move into the world of action games, and what better way to do that than by making Flappy Bird, or at least the very basics of a game like Flappy Bird. Please do not copyright claim this. So here I am. I have drawn this diagram to illustrate what we need to do. We need to draw some pipes. There needs to be a gap in between the pipes, like so. And we need to have a player character. We need to move the player character down on every frame. We need to also move them forward. And when we press a button such as X, then we want to move them up. And the big tricky part here is we want to do the collision detection. So when the Flappy Bird, when the player character collides with a pipe, it's game over. So we want to be able to tell when it's game over. But yeah, let's get to work. Let's take it one step at a time, and yeah, it should be fun. Thank you. So here we are in Pico 8. I have already created the usual three functions, which are called life cycle functions or life cycle methods, because they are called during the life cycle of the program, of the application. And now let's go and create our player character. I don't actually know where to start. Also, I will take this opportunity to look at the other things that Pico 8 gives us. So we can not only write code, but we can also draw stuff here. So there's a whole sprite editor. A sprite is just a cool way to say drawing or image in computer graphics. So I will go ahead and try to make some kind of, it can just be a ball in the beginning, but we'll see if we can make it look a bit nicer. So I don't know, this feels like a bird. This is giving bird, as the kids say. So do birds have blue eyes? Debatable. Okay, so this will be our bird, and I guess we will also need a pipe. So I will make this sprite bigger, and actually no, let's not use this to draw pipes. We can draw graphics in other ways as well, and it's good if we take a look at them. So this is going to be our bird. I just drew some pixels here, picked a color, and this is it. And you should note that it says 001 here. So this is the index, the number of the sprite. So to draw this specific thing on the screen, we would do SPR, which is a special function included in the Pico 8 standard library, as it were, and we give it the number and 1, and we then give it some X coordinates and some Y coordinates. And now if I run unclose function at line of 5, draw update, this should be all good. Function end does this. Wait a minute. Okay. Oh, sorry. I see what's happening. The stuff that I had from before, of course, I made a syntax error even before I started recording. Was also drawn to the screen, so I need to add a clear screen, and now it's no longer there. So that's good. So here we have a bunch of numbers, and to the naked eye, they don't mean much. So I will immediately go and change these into something with a bit more meaning and more context. So I will create a variable called player, and this will be a table. We learned about tables, I think 2 episodes ago, but basically they are a data structure that can hold other data structures. So it's just a way to group things and then either pass them around the program together or iterate through them, loop over them. We'll see many different uses to them over the course of this journey. So we'll say player dot x equals 20. Actually, I'll make it something else. So 64, and player dot y equals 64. So now I have effectively created a variable inside the table. So whenever I do player.x, this will correspond to 64. So if I go here, it's also called a key, by the way. The tables have keys and they have corresponding values. So key value pairs is what you might often hear. So now we can do player.x and player.y. And now we should see, okay, yeah, syntax error. Okay, yeah, because this is garbage. And now we see the sprite in roughly the middle of the screen. So we can see that we can just substitute these numbers for these variables, and in particular these keys in this player table. So that's great, but why is that? Also one more thing. I will also say player.sprite equals 1, because right now this 1, whenever I look at it, I will have to, let's say I come back to this project in 6 months, I see 1, okay, no idea what that means. I have to go here, I have to find the number 1 sprite, which granted is not very difficult. But still, I can just say player.sprite here, and now I will see immediately that, okay, this is drawing the player sprite. So that's good, nothing changes. And now in the update, I want to start moving the player around. So let's go and do our buttons. If button 0, then player.x plus equals or minus equals 1. And now if I, okay, again, I'm sorry, end. So now if I push the button that corresponds to 0, which is the left arrow key, it will modify this variable. Player.x will become 1 less than it was before. And then in the next draw, it will then be drawn 1 pixel to the left of where it was drawn before. So now I can just hold left and it will move. So this is how we create an illusion of movement. We just change the values by a little bit at a time, and then we draw it very fast so that our eyes are tricked. I will now create 2, 3. So this is right, up, and down. So now up is y. So remember, y goes, the smaller the y, the higher on the screen it is. In computer graphics, we always start with 0 and 0 in the top left. So let's say, and this should be plus. And now if I got this right, then I can move this in all four. Oh no, something is wrong. Player.x, y. And now I can move this in all 4 directions, which is great. But actually, we don't even need to move our bird in all directions. We need to constantly move it to the right and constantly move it down, and then sometimes we want to move it up as well. So I will go here and I will create a new key in the player table called dx, which will be, let's just say 1. And I will also create a variable or a key called dy, which will be 0. And I will also create a key called grav, short for gravity. And I'm going to call this 0.2, just random values. And now what I want to do is, and actually I'm going to say player.terminal, okay, max y equals maybe 2, let's say. So, okay, a lot of things. D, I think, stands for delta, and delta is a maths term for change. So what we want to do is, in this update function, we want to calculate how much should my x and y change this frame, and then at the end of the update function we will apply it to our x and y. So for example, I don't need this at the moment. I know that I want to move my player to the right each frame by some amount. And to move my player to the right, I need to increase its X value. So I'll maybe actually start it a little bit closer to the left of the screen, like this. And now I will say player dot X plus equals player dot dx. Save, run, and now it's moving to the right. Because every frame we're adding whatever we have in this value to our X. And we can set this to be 1 because in Flappy Bird there is no horizontal movement. We are always moving to the right at the same velocity, the same speed. For the Y, however, we can do player.y, player.dy is gravity. So we want to say, and this is player.gravity. So we want to say that your downward motion, actually let's make it plus equals gravity. So your downward motion is going to be affected by gravity, and we apply the gravity to it on each frame. So let's see what we get now. Okay, we get okay, of course I had to be clever above, so let's say grav, nothing's happening. Player.dy, okay, so player.dy is getting the gravity, and let's say the player.y, we need to add the player.dy. So the change, we need to add the change to our position. So now, woof, it's going down quite quickly. So I want to limit this. I want there to be a maximum speed that it can go down. So I will say if player.dy is greater than player.maxy, then end player.dy equals player.maxy. So now it goes down, it accelerates a little bit and then starts going down smoothly, which is basically what we want. So now we have some forward motion and we have some gravity. So now I want to occasionally jump as well. So now I will finally use a button, and I will say if button pressed, because I only want to count it once. And I will call this Shift X. So, and this can also just be 5, I think. Let's hope. So if the X button is pressed, then I want to say player.dy minus equals player.jump force. And now you know that we do not have this variable yet. Player.jump force equals maybe like 4 or something, so quite a lot. And it actually, yeah, so minus equals because we want to go upwards, so we need to subtract. The y needs to get smaller. And I also need to leave this to the very end. And I will also leave this, put this to the very end as well. So here we are doing some checks, some calculations. We see maybe buttons are being pressed, maybe the y velocity is already too great. If so, we adjust some things, and then in the end we just apply the dx and the dy. So now if I run this, this looks quite good. Great. Perfect. So now I can get rid of this, and I guess we can just draw some obstacles and call it a day, right? Yeah. So let's see. Let's draw some obstacles. How can we draw some obstacles? Let's go and let's just do 2 pipes and we can give them collision detection and call this our work in progress, most basic prototype, and then make it look better in the next episode. So I'm going to create a variable called pipe. It's going to be an empty table. It's going to have a how to do this. It's going to have an x position. Pipe.x equals, I'm going to set it to something, and then they can see how it will work out later. So let's make it 80. And I don't really know. Okay, let's start with this. So let's say that we have a pipe. Oh, and the pipe.y can be 0 because we want to start drawing it from the very top of the screen. So now in our draw function, we can there is a function called rect, which will draw a rectangle at a given coordinate. So I'll press escape, I'll type help rect. Draw a rectangle or filled rectangle with points at opposite corners given by x 0, y0, x1, y1. So this means that we need to give a top left corner and a bottom right corner, and this will draw a rectangle from that corner to the other corner. So we can say pipe.x, pipe.y. So this is the top left corner, so we set this there. And the bottom right corner will be pipe.x plus pipe.width, which does not exist yet. And the height will be pipe.y plus pipe.height. So we need to go and create these keys in the table. So pipe.height, I'm going to make it cover the whole screen, and I'm going to make it 20 pixels, 32 pixels wide. So now if we go and draw this, we should see something on the screen. And indeed we do. I will make it maybe 1 pixel shorter so that we can see the rectangle end, and indeed, so we have a white rectangle. Perfect. I'm going to call this our pipe. And actually, we can also, there's also a different function called rect fill, which will fill the pipe. So might look a bit nicer. I don't know. Okay, so we have drawn a pipe across the screen, but actually we want to draw effectively 2 pipes. So how should we do this? Maybe I can just do pipe and then pipe 2. Pipe 2 equals empty table. I will copy this. And I will make this, the height of this, let's say 40. The height of this can be whatever. The width can be the same. This all needs to be pipe 2, pipe 2, pipe 2, pipe 2. And now here, the x, I want to say this is 80 like it is above, but in case I want to go and change this 80, I want to say that this x should be pipe.x. And this y should be pipe.y plus pipe.height plus gap. And gap is a variable that does not exist, but it will be the height of the hole between the 2 pipes. So let's go and define it. I'm going to make it 52 or 50, round number. 50. So, and the height is whatever, because it's going to go below the screen. If we would want to, we could sum up all of this and deduct it from the height of the screen to make it line up perfectly, but I'll leave it be for now. And yeah, this is it. So now I will go down to the draw. I will copy this. How did Okay, and now if I just change this to pipe 2, I think it should work. Pipe 2. And it does work. Perfect. And if I change the gap, I want it to be smaller so it's more difficult, 20, that also works. And I can go change the X in like one place, and then it's further. Perfect. So we have a pipe, we have a bird. I want to make it easier for me, so I will do 60 and make this like 70. Okay, so we can now glide through the pipe fairly easily. Maybe the player can start like almost from the very left edge of the screen. So now we can draw the things that we need, but we still need to check for a collision. So how to check for collision? Well, luckily Pico 8 has a pretty great community. So if you search for Pico 8 collision or Pico 8 overlap or whatever, then you'll find a few examples of how to do this. And if you can, anytime that you can, like really phrase your problem in a specific way, like such as, how can I know the distance between 2 points? Or how can I don't know, calculate the radius of a circle or whatever? Or how can I detect if 2 rectangles are colliding with each other? Then you can look for it and you'll probably find something. So here, this is a very clever solution to collision detection, in that it is actually looking for no overlaps. So it's checking if so I'll just read it from here. It can be easier to figure out if 2 boxes do not overlap than to figure out if they do overlap. So basically, if these 2 boxes do not overlap, which is done by these calculations, then we can just reverse that, and then they are overlapping, right? So we can take this function overlap, and I will just add it somewhere. I'm just gonna go and add it to the top. Function overlap, and let's see what this does. So this takes in an A and a B, and A has an X, which is great. We also have an X, and it has a W and an H. So instead of a width and a height, we're talking about W's and H's. Okay, no problem. We can go and just change that here. It makes our code shorter as well. So height, width, pipe.height, pipe.h. And now in the draw, so we also had these guys, x, y, pipe.w, pipe.h, pipe.h, and pipe.w, save, oh no, save, run, everything still works. And now, so now we are drawing the pipes. Now let's check if we have an overlap. And I'm just going to maybe create a variable. Oh, actually, I'm now looking at our player, and player does not have a height. So what is the height of our player? And what is the width of our player? Well, it would be perfect if we could somehow say that, okay, if this part of the sprite is not touching the pipe, then this is not a collision. But in computer programming or in game development, you very often just guesstimate these things. So I'm going to say that this entire 8 by 8 square is going to represent our player in the code, and this 1 pixel box difference, it will be so small that the player cannot tell that we are actually, using a slightly bigger box than the actual player itself is represented as for collision detection. So this means that the player height and width is 8, because this is an 8 by 8 square. So now in the update function, let's say in the end, we can do if overlap. So player and pipe, then end, and what can we do? So this should be a way to make the program like crash. It's just making sure that assert, and then it expects something to be true here. So false is not true by definition. So this should crash. So let's see if we can now collide with our pipe. Up, assert failed, false. So this means that the collision is working, but it's not yet working for the bottom pipe. So let's just check that as well. If player pipe 2, then assert false. Aha, okay. Well, maybe it'll be fine. It seems to be a bit eager. Let's see if I have... okay, because I am already detecting the collision before I am drawing the player to the screen. So if I put the collision detection here, then it should allow the player to get closer. Yeah, perfect. So this is what we want. Okay, and this is it. I will just do one quick change. So let's say game state equals playing, and I want to say draw. So I always want to clear the screen. If game state is equal to playing, then end, and I'll just move all this stuff here. Bear with me. If game state equals game over, then end, and I will just print game over, and somewhere roughly in the center. And now if either of these are true, then I want to say game state equals game over. So now we should see a message, game over, being rendered to the screen whenever we collide with the pipe. So let's try the top pipe, game over. Let's play again, bottom pipe, game over. Okay, perfect. So we learned to use the sprite editor. We had some practice with programming tables, and we also saw that the Pico 8 community can be a great resource, and we used a collision function here. I will also just credit Mr. MBoffin here. I will just find the function and I'll say thank you, MBoffin, so that if somebody else finds my code, then they know where I got it from. Maybe even add the link. And yeah, that's it for now. Thank you very much, and in the next episode we'll make this a bit more full-fledged. So yeah, see you.